All right, let's get right into it. If you're here, I'm guessing your Honda's check engine light is glaring at you, and you're staring at this mysterious code P0523. Well, today, we're going to put on our detective hats, solve this thing together, and figure out exactly what your car is trying to tell you. Let's jump in with the first clue.
So you've probably noticed it, right? The engine's running a little rough, the performance just isn't what it used to be, and that little light on the dashboard is just staring at you. That P0523 code isn't just some random number. It's a very specific clue, a message straight from your car's main computer. Think of it as the first piece of evidence in our little investigation.
You know, any good investigation starts by actually understanding the evidence. So our first step here is to decode that clue. What is the P0523 code really saying?
Okay, here's the technical breakdown. The P0523 code means your car's brain, the powertrain control module, or PCM, has spotted a crazy high-voltage signal, and it's coming from a very specific part, the rocker arm oil pressure sensor. We're talking 4.79 volts or even more. And listen, this isn't just a quick flicker. The computer has to see that high reading for at least 2 whole seconds before it sounds the alarm.
And what's really interesting here is just how specific this all is. The PCM is like a super strict detective. It's not going to flag this code unless every single one of these conditions is met. You need the high voltage for that full 2-second duration, and it has to happen while your engine is below 4,000 RPM and your coolant is already warmed up to at least 140 degrees Fahrenheit. It's a very specific set of circumstances.
All right, so we've decoded the clue. Now it's time to do what all good detectives do. Line up the potential culprits. Based on what we know, there are 5 main suspects that could be causing this high voltage reading. We're going to go through them one by one, starting with the most common and, frankly, the easiest one to check.
Our first and most common suspect is something surprisingly simple, just a bad connection. I know it might not sound very dramatic, but before we start thinking about pricey parts, the problem could literally just be a poor electrical handshake between the sensor and the car's computer. It's like trying to have a phone call with a ton of static on the line.
So, what causes a bad connection in the first place? Well, over time, parts just wear out. The little metal terminals that connect the wires can get corroded, kind of like rust, especially if they get wet. Or simply from the engine vibrating day after day, they can work themselves loose. The key thing here is that sometimes the fix is as simple as cleaning and tightening a connection.
Let's move on to our second suspect, an open circuit. Now this sounds technical, but the idea is actually pretty simple. It's like a broken phone line. The signal from the sensor is supposed to travel down a wire to the PCM, but somewhere on that path, there's a break. The message just isn't getting through clearly.
That break can be a wire that's physically snapped, or maybe it's a problem right at one of the connection points. Either way, the communication line has been cut, so the PCM is expecting to hear from the sensor, but instead it gets, well, a very loud high-voltage burst of static, which it reads as the P0523 error.
Of course, sometimes the problem isn't the connection at all, but the messenger itself. That brings us to suspect number 3, a faulty rocker arm oil pressure sensor. The sensor's whole job is to report the oil pressure accurately, right? But if it's broken, it can start sending out bad information, kind of like a faulty thermometer that always tells you have a fever.
A sensor can fail in a couple of ways. The electronics inside it might just die, or the wiring that's physically attached to the sensor could be damaged. In either case, it's feeding the car's computer total garbage, and that high-voltage reading is the result.
Now, for a suspect that's a little less common but really important to consider, the software. It's totally possible that all the hardware, the wires, the connectors, the sensor, is perfectly fine. The issue could actually be with the program running on your car's main computer, the PCM. It might just be out of date and not interpreting the data correctly.
Yep, just like your phone or your car's computer sometimes needs an update. Manufacturers find bugs and they release new software to fix how the system reads sensor data. So if your car is running an old version, it might mistake a normal signal for a big error.
And this brings us to our final and most serious suspect, the brain of the whole operation, a faulty PCM. Now, this is the least likely culprit, so don't panic, but it's a possibility we have to consider to be thorough in our investigation.
If the PCM is the problem, it means the computer that's supposed to be diagnosing issues is the thing with the issue. This could be because the unit itself is just defective, or maybe it was installed incorrectly during a previous repair. Basically, the detective has gone rogue.
Okay, so we've lined up our 5 suspects. Now for the most important part, right? Matching each problem to its proper solution. Let's see how this all comes together.
And this lays it out beautifully. This table is your cheat sheet. For every suspect on the left, there's a clear, direct fix on the right. Got bad connections? You check, tighten, or replace them. An open circuit? You find the break and you repair it. A faulty sensor or PCM? You replace it. Outdated software? You update it. See? It's a logical process of elimination.
We've gone from a totally mysterious code to a clear list of what could be wrong and how to fix it. But before you go grabbing your toolbox, there is one last, absolutely crucial piece of advice we need to talk about.
And here it is. This is the most critical takeaway from all of this. While it's fantastic to understand what might be wrong with your car, diagnosing modern vehicles takes specialized tools and a lot of expertise. This knowledge is really meant to empower you, not necessarily to turn you into a weekend mechanic for this kind of problem. So now you're not just walking into the shop saying, "My check engine light is on." You can have an intelligent conversation. You can ask, "Hey, could you check for a bad connection or an open circuit before we look at replacing the whole sensor?" You understand the possibilities. So the final question really is, now that you're armed with all this knowledge, what are you going to ask your mechanic?